Patient Zero: Solving the Mysteries of Deadly Epidemics by Marilee Peters. Chapter 6, Part 1: Mystery in the Jungle, Ebola in Zaire 1976. The room was stuffy and windowless. Paint was peeling off the walls, leaving damp, scabby patches of discolored plaster. But the floor was clean, and so was the narrow iron cot in the corner. A man lay on the cot sweating. His eyes were glazed. The only sound was a faint wheeze as he panted for breath. Mabalo Lokela was very sick. It was September 1976, and Mabalo was in Zaire, a country of steamy, sprawling jungle and congested cities in Central Africa. Zaire, now known as the Democratic Republic of Congo, was not a good place to be sick. The country was still recovering from almost a century of brutal colonial rule by Belgium. Under colonialism, all of the profits from Zaire's rich natural resources, rubber, iron, ivory, and diamonds, went to the wealthy Belgian landowners. Meanwhile, the Zairean people had labored in the mines and the rubber plantations for low wages, forced to live in poverty without schools, hospitals, good sanitation, or clean water. Even after the country won its independence from Belgium in 1960, there was political instability and the country fell under the rule of a powerful dictator. Zaire struggled to recover, and there weren't enough doctors, nurses, and clinics or drugs to treat everyone needing medical help. Mabalo's hometown in Zaire's remote northern Equator province was a particularly unlucky place to fall ill. Yabuku was surrounded by jungle, hours away from rutted dirt road from the nearest town. The village had no doctors, just a clinic run by an order of Catholic nuns. Mabalo, the village school teacher, was just back from a hunting trip with family and friends from the surrounding villages. Now he had a raging fever, a splitting headache, and a body racked with cramps. Malaria, he was pretty sure. Mabalo had been ill with malaria before. Mosquitoes bred in the low, wet fields cleared for coffee plantations, and since no villagers could afford screens on their windows, everyone was vulnerable to the shaking fever. He lay in one of the Yambuku mission's examining room. He hoped that the nuns might have some drugs left over from their last shipment of supplies from Europe. He'd got a shot, go home, and hope that the fever receded enough so that in a week or two he could work again. The nun who bustled in to treat Mabalo agreed that yes, it seemed he'd got malaria again. Sister Beata wasn't a nurse. None of the missionaries had any formal medical training, but she'd seen many cases of malaria. She filled a glass syringe with the anti-malarial drug chloroquine and gave Mabalo the injection he'd been waiting for. Soon he was making his slow way home, leaning heavily on his wife's Mbusu's shoulders. At first, it seemed as though Sister Beata's injection was working, as it had many times before. But after a or two, Mabalo's fever returned with a vengeance. Soon he was too weak to get up, and his body was ravaged by terrible bouts of diarrhea and uncontrollable vomiting. His wife and two oldest daughters struggled to care for him. Neighbors took in the younger children as the crisis in the family's hut deepened. In desperation, Mbusu begged the nuns to visit her husband, hoping they might be able to cure him. When the sisters entered the family's small hut, Mabalo was lying on a low bed. He was covered in sweat and gasping for breath. Patches of dark blood were spreading from his ears and pooling beneath his nose and eyes. As they stared, terrified by the change that had come over him, Mabalo convulsed and vomited a stream of blackish blood. Mbusu turned to the frightened nun beside her. Sister, can you help? Do you have any medicine that will cure him? Slowly, Sister Beata shook her head. This is new, she said quietly. This is definitely new. The virus that had infected Mabalo was causing his internal organs to disintegrate into a soupy mess that seeped from his orifice and through his skin. With every retch, Mabalo released millions of infectious microbes into his surroundings. Every blood and vomit soaked rag his daughters washed was a time bomb of lethal microorganisms. Sister Beata was right. This disease was new, and it was very dangerous. Help us. For 7 long days and nights, the nuns and Mbusu fought to keep Mabalu alive. But at last he was claimed by the nightmarish illness. Surrounded by her children and helped by her family members and neighbors, Mbusu began preparing for her husband's body for funeral. Together the group carefully washed the body, sponged away the thick crusted blood. They would sit with the body all day and all night before carrying Mbalo to his grave just outside the family's hut. As the wails of mourners reverberated through this hot, still air, the nuns gathered in prayer in the mission's tiny church, felt a sense of relief. Mabalu's terrifying illness was over. Life could return to normal in the village and the mission. But a few days later, everyone began getting sick. Mabalu's wife, his eldest daughter, his mother, his sister, and his mother-in-law were the first to come to the mission clinic suffering from fever, headache, vomiting, and diarrhea. More followed. Within days, 21 people who had attended Mabalu's funeral were showing symptoms of the same violent illness. Others in the village and throughout the surrounding area were falling ill as well. The nuns, with their limited knowledge of medical procedures and scanty supplies, struggled to comfort the dying. Then they too began dying. Sister Beata was among the first. In the mission office, Sister Marcella, the Mother Superior, hunched over the shortwave radio, sending out message after message to the outside world, pleading for help. The fever was spreading fast, and it killed almost every person it touched, young or old, healthy or frail. For the nuns, for the grieving families, for the villagers numb with fear, there were so many questions. What was causing this terrible disease? Why had it chosen to strike their village? How was it being spread? And how could the living protect themselves from this killer? A microscopic question mark. As the 1st of October dawned in Yamboku, the epidemic was in its 3rd week. Already, well over 100 people were dead. Alerted by Sister Marcella's calls for help, doctors in Zaire's capital city, Kinshasa, arrived to collect blood samples that they would analyze to try to identify the mystery illness. There were no longer enough living staff at the mission to care for the sick and dying. Sister Marcella sent the remaining patients home and ordered the mission's gates to be chained shut. The nuns gathered together in the chapel to pray and wait for death. With no clinic to care for the sick, fever patients were taken to neighboring villages to be cared for by family members, spreading the infection throughout the region. Village elders warned people to stay home. Schools and shops closed, social gatherings were discouraged, and trees were felled to block the roads, preventing travel between villages. Almost overnight, the epidemic zone became a network of ghost towns. Meanwhile, the blood and tissue samples the Kinshasa doctors had collected were being studied around the globe. Scientists were peering into microscopes and realizing with a jolt of fear and excitement that they were looking at a virus that had never been seen before. In Belgium, 27-year-old Dr. Peter Piot, a researcher in the microbiology lab at the Prince Leopold Institute of Tropical Medicine, was one of the first to look down the barrel of a microscope at the virus. He soon realized the mysterious microbes were lethal. Laboratory mice injected with the tiny amounts died within days. Doctors in Zaire had suspected the disease might be related to yellow fever, but all the antibody tests were coming up negative. With its curved, whip-like tail, Peter thought the virus looked like a question mark taunting him and his colleagues. When the director of the institute told Peter that the World Health Organization, also known as WHO, was sending an international team of scientists to Zaire, Peter didn't ask to go. He demanded to be sent as Belgium's representative. This deadly virus was a question, and he was determined to find answers. On the hunt. Days later, sitting on a flight to Kishawa, Peter started to wonder what he'd gotten himself into. Seated next to him was a Belgian diplomat who was furious that an inexperienced doctor was part of the team fighting the mysterious killer disease. Intolerable. We're facing a terrible epidemic and all they could find is you? How old are you? 27? You're totally green. You're barely even a doctor. You've never seen Africa in your life. The taxi ride from the airport through Kinshasa didn't help to calm his growing nervousness. Everywhere he looked, there were throngs of people, and the sticky heat and humidity had him panting. He'd hardly been out of Belgium before, and never anywhere as unfamiliar as this city. He had been foolish to sign up for this. How had he been foolish to sign up for this mission? The hastily assembled group of scientists knew they needed more information. They decided to send a scouting team to Yambuku to investigate the epidemic and try to find out how it was spreading. Who was willing to volunteer? Before the question was even finished, Peter had his hand up. Meet the microbe. Watch out, I've got a nasty virus. You don't want to catch it. We've all heard that before, but what exactly are viruses? A virus is a type of microbe or single-celled organism. Microbes are the oldest and most numerous life form on Earth, and they are essential to human life. There are several types of microbes, including bacteria, fungi, viruses, and the lesser-known archaea and protista. Without microbes, we couldn't digest our food, breathe, or break down waste. But some microbes cause potentially lethal diseases like Ebola. Viruses are the tiniest and in many ways the strangest of all types of microbes. Scientists can't even agree whether viruses are alive. Until a virus comes into contact with the host cell, it is nothing more than a lifeless bundle of DNA. But once it makes contact with cells in your body, the virus springs to life, hijacking the cells and using them to reproduce itself and spread. Illnesses from the common cold to AIDS and Ebola are all caused by viruses. And many of the symptoms of viral illnesses, such as coughing, vomiting, diarrhea, help to spread the virus to new hosts. Collecting clues. Yeah. Peter choked from the searing pain in his throat. Around him, a circle of men laughed uproariously. As soon as his eyes stopped watering, Peter joined in the laughter. It was his first taste of arak, a powerful homemade alcohol popular in Zaire. As Peter was discovering, sharing a drink of the fiery liquid with community leaders was a good way of gathering information about the epidemic. He had arrived early that morning in Yalakonde, the nearest village to Yambuku. As he stepped from the jeep, he was struck by the brooding silence. No children played in the central square. No adults lingered to gossip outside huts. No shops were open. At first, only a few people ventured out to talk to the foreign doctor. But later, as the cup of arak was passed around, the elders began to tell him about the outbreak in their village. They brought Peter into the huts of the sick so he could see the suffering that the disease inflicted on its victims. As frightened as he was, Peter felt useful in a way he never had while working in the lab in Belgium. He took blood samples and interviewed family members, noting the names of the dead when they had died and their relationship with other fever victims. By visiting every village within driving distance of Yambuku, the scouting team determined that over 200 people had died of the fever and there were still infected victims. From soccer to funerals. Each night when the WHO team members returned to their headquarters at the Yambuku mission, they shared the data that they collected and the notes they had taken. Soon, the scientists had enough information to plot graphs of the disease, showing the number of cases by location, age, and gender, and the dates of known deaths. To everyone's relief, the graphs indicated that the worst of the epidemic was probably already over. The scouting team was doing its job, collecting enough information so that a full-scale investigation could be set up in the region. But Peter was frustrated. He wanted to find answers to the questions that were tormenting him. How was the disease being transmitted? Why had it spread so quickly from Mabalu, Lokela, to the rest of the village? And where had the virus come from? One evening, Peter drove to the village of Yamatile Moke. The village elders welcomed him, and soon a lively debate about the strengths and weaknesses of Belgium and Africa soccer players started. Peter stayed and talked through the evening, and he returned again the following night. Unlike the systematic data gathering he did during the day, during these conversations, Peter took no notes. He just listened, piecing together information about local customs and culture. He wasn't sure how this would help to fight the epidemic, but he knew that if he wanted to help these people, he needed to understand them better. Peter's instincts soon proved right. One evening, the conversation turned to the preparations for the latest fever victim's funeral, and as they spoke, Peter learned why a pattern of new infections followed each funeral. It was customary for family members to honor a deceased person by washing the body and sitting with it overnight before burial. These practices meant that there were many opportunities to come into contact with infected blood and body fluids. Peter immediately advised the elders to put a stop to the customary funeral rituals for fever victims. As he reviewed the data he'd collected, Peter noticed something else that worried him. A high number of young women were contracting the disease. Usually in an epidemic, more deaths were to be expected among the very old or the very young, those without reserves of strength to fight the disease. But in this case, it looked as though the most vulnerable were women between 18 and 25. The number of deaths of young women was more than double that of young men. What could be the explanation? Peter recalled that what he'd learned about the activities at the Yambuku Mission Clinic before the epidemic had forced it to close. Despite a tiny staff and only the most basic equipment and supplies, the mission had served the medical needs of thousands of people throughout the region, including offering prenatal care for pregnant women. Peter was willing to bet that many of those expectant mothers were between the ages of 18 and 25. Could there be a connection between the mission and this terrible epidemic? Peter knew he needed to get a look at the clinic for himself. Tool of the trade, qualitative research. When Peter Piat arrived in Zaire, he had no formal training as an epidemiologist. Very few people at that time did. Aside from a few internationally recognized organizations, such as the U.S. Centers for Disease Control and Prevention in Atlanta, Georgia, there were hardly any research laboratories in 1976 that specialized in epidemiology. This meant scientists learned epidemiology on the job. The investigative team sent to Zaire took blood samples, drew detailed maps of epidemic-stricken areas, asked the same questions of people over and over again, and noted down everything. But Peter Piot realized that in addition to the how many approach of the quantitative research, for example, finding out how many people had come into contact with each patient and how many of those people got sick, the researchers needed to add the element of why. They needed to uncover why some people were getting infected while others weren't. And that meant spending time with villagers to learn the details of their everyday lives. This kind of approach is called qualitative research. As Peter wrote years later, it's like detective work. You take blood samples also, but the essence is talking, 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 and understanding. Cracking the case. As Peter toured the empty rooms with Sister Marcella, he told her about the high number of deaths among young women. Had anything unusual happened at the mission's prenatal clinic, he asked, around the time that Mabala Lokela fell ill? Sister Marcella smiled as she remembered those happier days when the mission's courtyards had been filled with the bustle of patients and families. She told Peter proudly about the excellent prenatal care that young mothers received at the clinic, and in particular the popular weekly vitamin shots. All pregnant women visiting the clinic were given an injection of vitamin B12. Name that virus. Laboratory scientists today can choose from a few different methods of identifying a virus. One of the oldest methods, first developed in the 1990s, is to grow a culture of the virus. The scientist places a small sample of the infected blood or tissue in a cup, along with cells in which the virus can grow. The culture, as the microbes grow in the culture, changes in the cells will be visible under a microscope. By observing these changes, the scientists can identify the virus or bacteria that is causing the disease. In 1890, German scientist Robert Koch suggested 4 guidelines for scientists to follow to help them determine if an infectious organism, such as a virus, is the cause of a specific disease. These rules, still followed by scientists today, are called Koch's postulates. A scientist must be able to answer yes to each of the following questions before concluding a virus causes a particular disease. Is the organism found in people with disease and absent in people without the disease? Can the organism be grown from blood or tissue samples taken from a person sick with the disease? When the organism is given to a healthy person, do they develop the disease? Can the organism be grown again from blood or tissue samples from this second person? With a growing sense of dread, Peter asked to see where the drugs and medical equipment were stored in the clinic's small dispensary. He opened drawers and cupboards one after another. Finally, he turned to Sister Marcella. There are only 5 syringes here for the entire clinic. How did you manage to give so many injections with such a small stock? The sister replied matter-of-factly that each morning the syringes were sterilized. After that, they were used over and over again for all the patients treated that day, with a quick rinse between uses. On their meager budget, she explained, the clinic couldn't afford to buy more syringes or needles. Peter realized with horror that the nuns who had given Mabalo Lokela his shot of chloroquine had unwittingly spread the infection to every pregnant woman in the village through the unsterilized needle. Here was the link he was searching for. The epidemic had been spread by the very clinic to which people had turned for help. Peter carefully bagged 2 of the syringes to take back to Kinshawa for testing. I'd bet anything these are both infected, he thought sadly to himself. The scouting team's findings were correct. The epidemic had spread through unsterilized needles and through contact with infected patients in the mission clinics and at funerals. The last infected patient died on November 5th, and there were no further cases reported. The international scientific delegation continued to work in Zaire for several months, collecting more information about the mysterious disease that they began to call Ebola, naming it for a nearby river. Where does Ebola come from? Peter Piat's team never learned how Mabalo Lokela contacted Ebola, but we now know it is transmitted to humans through contact with infected animals. The Ebola virus has been identified in gorillas and chimpanzees in Africa, and scientists think that in at least some outbreaks, the index case, patient 0, was either a local hunter or a customer who bought infected meat from hunters. Gorillas aren't the reservoir species for the virus, where the virus lives in between the human outbreaks, because Ebola kills gorillas almost as fast as it kills humans. The evidence currently points to African fruit bats as the reservoir species. Fruit bats may infect humans directly or transmit the virus to them indirectly through other animals. The key to preventing future outbreaks of Ebola is reducing the risk of animal to human transmission. This may sound simple, but it isn't. Here are some of the reasons why Ebola outbreaks are continuing in Africa. Disappearing forests, logging and farming are putting more people in formerly wild areas into contact with animals. War, refugees fleeing from wars often have to hunt for food. Climate change, habitats are changing and some animals are moving closer to human settlements. Poverty, there aren't enough hospitals or doctors in some areas of Africa. The road ahead. Researchers identified the Ebola virus as a filovirus, one of only 2 ever discovered. The filoviruses are a small family of viruses causing extremely lethal diseases in humans and other primates. Both the filoviruses, Ebola and Marburg, cause severe hemorrhagic fever, illnesses in which the victims bleed profusely. Ebola kills 88% of its victims, making it one of the most lethal diseases on the planet. In a Yambuku outbreak, 318 people were infected and 280 died. Between 1977 and 2020, there were 29 Ebola outbreaks in Africa and elsewhere, including 3 in the U.S. 4 workers at U.S. research facilities in Virginia and Texas who were accidentally bitten by monkeys developed Ebola antibodies in their blood, proteins produced by their immune systems in response to the Ebola virus. But the workers never developed symptoms, although the monkeys became sick with Ebola and died. This particular strain of Ebola, which is not dangerous to humans, was named Ebola Reston after the city in Virginia where it was first identified. At the time Ebola emerged in 1976, medical science seemed to be winning the war against disease, with powerful weapons like vaccines and antibiotics in their medical arsenal. Ebola reminded everyone of the vast number and diversity of disease-causing viruses and bacteria, and of how much scientists and doctors still had to learn about fighting disease. Hot labs. Microbiology laboratories around the world use a numbering system to identify their level of biosafety, the degree of risk that is involved in working at the facility. There are 4 levels. In level 1 labs, scientists work only with organisms that do not cause disease. In level 2 labs, mild disease-causing microbes can be handled. Level 3 labs work with serious diseases for which treatment or vaccines exist. Only in level 4 labs are the most lethal, highly infectious, and untreatable diseases allowed. To get clearance to study life-threatening microbes, level 4 labs must create hot zones, isolation chambers located either in a separate building or in a highly controlled area within the main lab. Before entering a hot zone, researchers dress in special coveralls, over which they pull a bright blue, heavy-duty pressurized hazmat, hazardous materials suit equipped with a breathing apparatus called a chimturian. Before entering and after leaving the hot zone, the researchers must also pass through a series of decontamination showers, a vacuum room, and an ultraviolet light room in order to eliminate all the potential traces of disease.